It turns out that a magical physical principle is contained within a car's braking system. Today, we'll delve into the role of brake fluid and the working principle of the braking system. This is the most commonly used disc brake for cars. Those of you who drive frequently should be familiar with it. This is the brake disc. It's usually made of high-strength cast iron, steel, or composite materials. The internal structure has a ventilation design to improve heat dissipation. It's fixed to the wheel hub and rotates with the wheel. And this is the brake pad, which is the friction material that contacts the brake disc, and it's installed in the brake caliper. When you press the brake pedal, the piston in the caliper pushes the brake pad to clamp down. The brake disc slows down, rubbing against the wheel until it stops. The inertia of a multi-ton car is very large when moving at high speed. Why does the driver only need to lightly press the brake pedal to achieve effective braking? In fact, this is due to the force amplification of the hydraulic system, and the brake fluid is a key ring. When you press the brake pedal applies pressure to the oil in the braking system through the connected master cylinder. The brake fluid is then transmitted to the brake caliper of each wheel through the pressure of the master cylinder. Inside the brake caliper, there are one or more pistons. After the piston is subjected to the pressure of the brake fluid, it tightly presses the brake pads against the brake disc to achieve deceleration. The main principle of the hydraulic system is Pascal's law. That is, in a closed fluid system, pressure applied to a certain point of the fluid will be transmitted uniformly to every part of the system. Therefore, in a hydraulic system, the force and area of different pistons or areas are proportional. The braking system uses this to achieve force amplification. Specifically, in the braking system, the master cylinder and the brake caliper have pistons, and the area of the master cylinder's piston is usually much smaller than the piston in the brake caliper. For example, if the master cylinder's piston area is 1 square centimeter, and the brake caliper's piston area is 10 square centimeters, which is 10 times the area of the master cylinder, according to Pascal's law, when you apply just 50 newtons of force to the brake pedal, the caliper piston can generate 500 newtons of force, thereby pushing the brake pads to contact the brake disc and create enough friction to achieve braking. This is an ingenious application of physical principles in engineering.